We're going to do detection of lipids, which is one of the macromolecule that has been introduced for you guys during the class session. In this particular session, we're going to do three types of experiment on lipid. The first one is we're going to do the detection of lipid, and then the second experiment we're going to do the separation of lipid using TLC, thin layer chromatography, and then the third experiment we're going to determine the free fatty acid concentration. Those are the three experiments that I'm going to introduce you guys for this current session, for this particular session. Okay. Our sample for the first experiment, which is the detection of lipids, we're going to use the liver extracts, milk, and olive oil. We have the liver extract, we have the milk, we have olive oil, and also our water. For this particular exercise, you guys should also looking at the manual to determine or to do for this exercise, for the exercise for this particular experiment, you guys need to look at your manual to answer all the questions for the lab experiment 1. Okay. So first, I'm going to do this experiment. So the first experiment, you guys need to determine which one is the positive control, which one is the negative control, and also your test sample. All right? And please answer that in your report. The first one is I need to add about half of this tube with water. And then 10 drops of my sample. Okay, in this instance, we have to determine which one is our positive, negative, and our test sample. So I have labeled my tube, this one with milk, liver, olive oil, and water. So the first one I'm going to add liver sample. Ten drop. That's all we need. One, two. Ten drop of milk as well. 3, 4, 5, 6, 7, 8, 9, 10. Olive oil. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course, just water. Okay. This is our sample. Now we have liver extract that has been dropped into the water, milk, and our olive oil. We have water as well. So the next step is we have to add 5 drops of Sudan 4. So for your first task is, what did you observe based on my experiment? So record your findings. And now I'm going to add Sudan 4, but before that I'm going to shake a little bit. Five drops each. 1, 2, 3, 4, 5. Then I'm going to shake them. This is our liver extract after addition of Sudan 4. I have our milk, 5 drops as well. 1, this is milk after addition of Sudan 4. I have olive oil. Olive oil after addition of Sudan 4. And the last one is water. I will leave it for 5 minutes. Okay? And after 5 minutes, I'm going to shake this thing again. And then we're going to see what happens after 5 minutes. I'll come back to that. Okay. Okay, 5 minutes has passed. Now what we're going to do is, I'm going to shake this thing again, gently again. So, based on this tube, based on my experiment, what do you find? So please record on your report. So you've seen here, this is our liver extract. This is our milk. This is our olive oil after 5 minutes. And this is our water. So based on the finding here, please write down your observation in the report. And of course, please determine what is your positive control and what is your negative control. As of now, I'm going to give you guys first answer, which is your positive control. The olive oil is your positive control, and the reason is, what did you see? There is the formations of the Sudan blue and the Sudan 4 did color the olive oil, separating the water from the oil. So we have this kind of separation between water and oil. And now I'm going to add detergent to observe this. Detergent can be any soap, even your dishwasher, even your dish soap can do the trick as well. So this is what happened after we add the detergent into our olive oil, which is our positive control. And now you guys see there is no formations of the oil layer. Now what happened here is it has been mixed with water and oil due to the presence of emulsifier, which is in this instant is the water, which is in this is the detergent. So now please record this finding in your lab report. So this is the end of our first experiment. Before we continue our experiment, make sure in the report you answer all the questions as well. We're going to detect the lipid compound using thin layer chromatography. So the sample we're going to test is milk. It's an egg yolk that has been prepared with a sodium chloride. Milk that also has been prepared with sodium chloride. .2% olive oil, 0.2% olive oil, 0.2% cholesterol, and then 0.2% lecithin. Beside our 5 sample here, we also have our TLC plate. Petroleum ether. Petroleum ether mixed with ethyl and acetic acid at 75-25 to 1 ratio. And the last one, we have isopropyl alcohol. These three has to be opened and prepared under fume hood. Beside that, we also have the iodine bead that also has been placed under the fume hood. I'll introduce you guys to the iodine bead later on. For the first step is we're going to take 1 ml of egg yolk, I'm going to take 1000 microliters or 1 ml of egg yolk using 1 ml pipette, 1000 microliter pipette. Then 1.5 ml isopropyl alcohol. For this, I'm going to use 5 ml micropipette. The tips for the 5 ml micropipette, it's larger than the 1000 microliter micropipette tips. Add 1 ml. and milk sample. Now we're going to prepare our TLC plate. The TLC plate have two sides. The one that have reflective, slightly shinier, this is the back. And then the one that have slightly, that are not reflective, have a quite dull surface, and this is the surface that we're going to use. All right? So now, what we need to do, we need to label our TLC paper. Use pencil and ruler. Approximately about 1 centimeter from the bottom in this instance I take 2 centimeter. Draw the line. And then since we have 5 samples of each our sample placed onto our TLC plate. For this, I'm using the 10p microliter micropipette. And you guys will notice the tips will be smaller as well. Then microliter of the upper layer. Another time acrylate upper layer of milk. Point 2% olive oil. Make sure they are well separated. They don't touch with each other sample between each sample. Point 2% cholesterol. And finally, 0.2% lecithin. And then let it dry for a moment. you can see the mark and make sure your sample is in touch with the neighboring sample, and also the label as well. And then we're going to add our solvent phase, which consists of mix between petroleum ether, ethyl ether, and acetic acid into this beaker that has been covered with the aluminum foil. And there's a small slit that allows the insertion of our TLC plate. Put TLC plate, leave it on the room temperature, let it dry, and now these are the state when they dry, and then put it into our iodine bead. And then you start to notice there is a coloration start to occur. Minute, we take it out from sample, and now we can start the measuring. This is how it looks. Okay, you start to notice the layer. There is a solution layer, and then our samples. Okay. So what we need to do now, we need to calculate the distance. The distance that we need is, there are two distances that we need. Now we start to see the formation of the band. Okay. So now we have our egg sample, milk, olive oil, our cholesterol, which is quite faint, and then our lecithin. So what we see, there are two types of band. We see the solution band, which is here, and then our sample band. We have this sample for eggs, the highest, the lowest. Then we have milk. At the same time, we also have this band for the eggs. And then we have the olive oil. And it has its own separation as well. And then we have this cholesterol. Unfortunately, we couldn't see any band formation on our lecithin. Okay, so we see here, we just need to circle with pencil our samples: egg yolk, milk, olive oil, cholesterol, and lecithin. So what does it tell? So what we need to do here is, we need to measure the distance first, the distance from the starting point to the solvent divided, and then also to measure the distance between our samples from the starting point. We need to measure it using the ruler. In this instance, we have the distance between starting point to our solvent is 5.2 centimeter. Here we have, I'm just choose the center point here, the bottom point here. For our cholesterol, we have approximately 0.5 centimeter for cholesterol. For our olive oil, we have 0.5 centimeter, 1 centimeter, and then we have a large band here, which is at the center, 2.5, the bottom is around 2, and here is 3. While for our eggs, for our milk, we have around 3.5 centimeter, and then for our last sample, the first band here we have 0.5, 1 centimeter, and then this about the starting 3.5 up until 4 centimeter. Based on the formula given, we need to calculate the distance, and then from here we're going to work out what are the components that present inside our samples. I think from straight away, by looking at here, we know that our sample eggs also contain cholesterol. So does, but our milk do not have presence of cholesterol. While we're looking at our olive oil sample, we also see the band that are aligned together with our cholesterol. That's the first indicator that cholesterol presents in our olive oil as well as in our egg yolk. Well, there is no presence of cholesterol in our milk products. Okay, thank you. For the last experiment, we're going to determine the free fatty acid concentration. So what do we need is our all stock solutions we have solvent mixture which consists of 95% ethanol mixed with diethyl ether. And then for the titration, we will use 0.1 molar potassium hydroxide in ethanol, and then we have our dye, which is phenolphthalein, 1% phenolphthalein mixed with 95% ethanol. For your information, I have transferred 25 ml of potassium hydroxide into our titration burette. So what we need to do now is preparing our sample. So what we need is 1 ml of our all stock solutions, and then we need to adjust with our solvent of solvent mixture up to 5 ml, which means we need 4 ml of our solvent mixed into our oil stock solutions. And the last step is adding 5 drops of our indicator. So now what we need to do is we need to titrate our potassium hydroxide into our mixture, and then we need to notice the formations of pink color. Okay. Okay, sorry. Now we did start to notice the formation of, not sure whether you could see on the video, but I did start to notice the formation of pink color. But then again, now start to see there is the pink color formations. It does stay for at least 10 seconds and then it starts to disappear again. Okay? So the volume we have from so it's all we need is about this 6 ml of potassium hydroxide. To change the color. So from here, we need to calculate using the equation that has been given in the lab manual. So it is your task to determine the concentrations of your free fatty acid based on my experimentations. And please answer all the questions given in the manual, in the lab manual. Thank you.